So the problem I had most difficulty with on the Physics 2211 Exam 1 was problem 3. A hypothetical binary star system consists of two stars, A and B, each with the same mass of 6.0 times 10 to the 29th kilograms. Star A is located at negative 2.0 times 10 to the 10th, negative 2.0 times 10 to the 10th, 0 meters, while star B is located at 2.0 times 10 to the 10th, 2.0 times 10 to the 10th, 0 meters. So, to begin with this problem, you have to find the change in position with the vectors. So, since you're trying to determine the force acting on star A due to star B, you have to subtract star B minus star A's distance. So you do this. So R final equals R2 minus R1, which is equal to B minus A, which is 2.0 times 10 to the 10th minus a negative 2.0 times 10 to the 10th, and then 2.0 times 10 to the 10th minus a negative 2.0 times 10 to the 10th, and then 0 minus 0 meters. And this should give you 4.0 times 10 to the 10th. I'll just write here. This should give you 4.0 times 10 to the 10th and 4.0 times 10 to the 10th, and then 0 meters. And then where do you go from here? So from here, now you have to find the magnitude of the vector. So now you have to find the magnitude of our final, which is equal to the square root of the new vector that you found. So 4.0 times 10 to the 10th squared plus 4.0 times 10 to the 10th squared plus 0 squared. So that should give you 5.657 times 10 to the 10th once you put in your calculator. And then after this, you need to find r hat to have all three components. So r hat final is equal to the vector that you got, so r final over the magnitude of r final. So this is equal to 4.0 times 10 to the 10th, 4.0 times 10 to the 10th, 0 meters over 5.657 times 10 to the 10th. And this should give you 0.71, 0.71, and 0 for r hat. And then, now that you have r hat, you can use the gravitational force equation to find the force of the vector force acting on star A due to star B. So this is what you do. So the equation is F is equal to the gravitational constant m1 m2 over r squared times r hat times negative r hat. And so for this, m1 m2 is basically just g m of star A, m of star B over r squared times r hat, negative r hat, which is equal to 6.7 times 10 to the negative 11, which is the gravitational constant, which is given in your formula sheet, and then the mass of star 1 and star 2, so it's 6.0 times 10 to the 29th, and since they're the same, you could square them, or you could just write them both out. 10 to the 29th, because it's easier for you to see. And then over, and then r squared is the magnitude that you found from taking the square root of the vector that you got. So this would be 5.657 times 10 to the 10th squared, because the bottom is squared. And then you have to multiply by our hat, which is negative. So you can just do this. You can just distribute the negative. So it would be negative 0.71, negative 0.71, and 0. So then you just put in your calculator, and what you should get is, which equals negative 5.35 times 10 to the 27th, negative 5.35 times 10 to the 27th, and 0 newtons. And these two should be the same since they have the same distance from the star, and they should be negative because our hat is negative. So, thank you.